Today we are going to talk about disk method again, but this time we are going to revolve around other axes. So in topic 8.9, we learned about disk method where we revolved around the x or y axis, and this time we're going to be able to revolve around other lines. So just a review from topic 8.9, let's go ahead and find the volume of a solid generated when the region in the first quadrant is bounded by the graph of y equals x-axis, the vertical line x equals 3. We would like to revolve that around the x-axis. Please hit pause, try it on your own, and when you hit play, I will talk about it. So we have the line y equals x, we stop at x equals 3. And so when we revolve it around the x-axis, we should have something that looks like this. So if it helps to draw a slice, go ahead and do that. And let's really take an up-close look at this slice. I need to know the radius and I need to know the height of this slice. So as always, the height of this is dx. These are vertical slices, so it'll be with respect to x. And then the height, the radius will just be x. It goes up from the x-axis, which is 0, up to the line y equals x. So we will use the same formula. This time our boundaries are from 0 up to 3. The problem told us so. X is my radius, so that is what I will square dx. From here, we will go ahead and do it by hand. So when you have 3 to the third over 3, one of the 3's divides out with that bottom 3, so you just end up with 9 pi. Alright, so this next unit is about revolving around other axes. So when we say axes, we mean other lines. So x-axis and y-axis are lines. They're just lines that we always look at, that we commonly refer to, so we can have our coordinate planes. We can look at revolving around other lines. Example 1, what is the volume of the solid generated when the region bounded by the graph of y equals 2x, the horizontal line y equals 2, and the y-axis is revolved around the horizontal line y equals 2. As usual, I would like to set up a graph. So here is my line y equals 2x. It will stop at the horizontal line of y equals 2. And this time I am revolving it around this line. So in the past, when I've revolved it around the x-axis, you can imagine taking this, going around very similar to our previous example. Here, we want to revolve it now around the y equals 2 axis. So if you imagine the shape of my solid now looks something like this. Very similar to before, we can cut out a slice, a disc, a coin, whatever helps you think about it. And as always, we need to find the radius and the thickness. So again, the thickness of this coin, of this disc, is whatever change in x you have. So this is dx. The radius here is slightly different. We are going to go back to previous topics where we had to take top y minus bottom y. We had to subtract. Here what you're going to do is you're going to take a look to see what forms this center and what forms this bottom piece of the disc. So here, the center was 2. It was that line y equals 2. That was the center of the disc. And then the bottom part of the disc was the line 2x. So you're going to subtract those two, and that forms your radius. So last time it was a little more convenient because up here, when we revolved around the x or y axis, our center was at a line where it's equal to 0. So if I wanted to, I could have put x minus 0 here. Because the top was x, the bottom was the line y equals 0, the x-axis. This time I don't have that luxury. I do have to subtract off a piece of it. If I don't subtract off that 2x, I would end up revolving a solid, I guess it would still be cylindrical. It just wouldn't have this shape. It would be a solid, almost square looking thing that when you revolve it, it would become a cylinder. So fortunately for us, we can still use the same formula. It's just that in this topic, you have to be careful when you have your radius. My limits are from 0 up to whatever gave me y equals 2. So because this was the line 2x, that means that 1 gave me 2. 1 comma 2 is my point where I stop rotating the solid. So I'm going to go from 0 to 1. My radius is 2 minus 2x squared dx. Okay, at this point, practice your U-substitution if you would like. Pause it here. And when you finish U-substitution, you should get 4 pi over 3. Example number 2. What is the volume of the solid generated when the region bounded by the graph of y equals 4x, the horizontal line y equals 8, and the y-axis is revolved around the horizontal line y equals 8? So we have another straight line, a little bit steeper than before. It is now being revolved around the line y equals 8. So the way I've drawn this, I will have to go into my words up here, but you can see that when I rotate this around the line y equals 8, I end up with a shape like this. Let's remove a slice of this disc. Here is my radius. My center would have been the line y equals 8. The top part of my disc would have come from rotating 4x. So one way to think about it is to remember that your center is like your top piece when you start rotating it. This is the top of your curve. So 8 minus 4x. Another way you can think about it is you can also draw the radius down here. It really won't matter which way you draw the radius because when you plug it into the formula, it's squared. So if you recall, the only reason it would make a difference if you flip-flop these two, if you did 4x minus 8, would be that it would turn out negative, but it won't matter because you squared it. So pi, again, I need to figure out my boundaries. Here, I go from 0 up to a point that gives me 8. So what input into 4x gave me 8? It would have been 2. Similar to before, you can go ahead and practice your U-substitution if you'd like to pause here. And when you finish doing U-substitution, this should become 42 2/3. Which, if you turn it into an improper fraction, you'll notice that you do get answer B. Unfortunately, here, if you have it as a mixed number like this, you'll notice that won't show up in your answer choices. So recall how to change a mixed number to an improper fraction. You take the denominator, multiply it by the whole number, and then add the numerator. So here it'd be 3 times 42, which is 126, plus 2, 128. This next example asks which of the following would give a volume of a solid. So I hope that you see already we can eliminate C. C does not match the formula. It doesn't have a squared. The rest of them have a squared. However, remember, we have to take the radius and square it. So if you take a look at D, this is taking arcsine, squaring it, and then putting a 1 minus in front. This would have been similar to something we've done in the past where we had to have 1 minus and then squaring something like this. But if you want all of the radius squared, you need something more like A or B. So D is out. So we need to take a look at the graph of y equals sine x up to the vertical line x equals 1. So if you recall, sine has a maximum at pi over 2. So sine were to keep going, it would be something like this. Pi over 2 would be here, which is approximately 1.5 something. So you know that sine at 1 stops before it gets to that maximum. So I'm looking at this piece right here up until here. Which of the following gives the volume of the solid generated when region R is revolved around the vertical line x equals 1? So I am taking this line, x equals 1, and I'm going to rotate this piece around x equals 1. So if you can imagine, my rotation should look something like this. You'll notice here, because we're rotating around a vertical line, this time our slices are going to be horizontal. So if we draw our disk, so it's like we cut a slice from this solid object, solid 3D object, we have this disk. The center of my disk would have been that line x equals 1. And the outside of my disk is sine x. However, because I need to find everything with respect to y, I need to solve for x. So take the arcsine of both sides to get x by itself. So you'll notice this curve, instead of calling it y equals sine x, I can now call it x equals arcsine of y. So I'm going to have 1 minus arcsine of y. So that is my radius. And now I just need to figure out my limits. We can see here A and B both have that same radius. So here, question is, should I look at the x-axis, which would be answer B, 0 to 1, or should I look at the y-axis, 0 up to sine of 1? So I plug in 1 into my function, and I get sine of 1, whatever value that is. So you'll notice because they are horizontal slices, I'm adding up all these slices horizontally. I need to use the values on the y-axis. So go from 0 up to sine of 1. So again, remember College Board knows mistakes that you might make. So you'll notice they did put in answer B where the limits are 0 to 1. So please be careful whenever you have vertical slices, such as the previous problems, your limits are on the x-axis and everything needs to be with respect to x. When you have horizontal slices, everything needs to be with respect to y and your limits need to be on the y-axis.